According to the National Electrical Code, a main bonding jumper is required for a mobile generator connection. The main bonding jumper is a conductor that connects the grounding electrode conductor to the neutral conductor at the service entrance. This jumper ensures that the grounding and neutral systems are properly bonded, which is essential for electrical safety. In the context of electrical systems, bonding refers to the intentional connection of metallic parts that are not intended to carry current. This includes things like equipment enclosures, metal conduit, and other non-current carrying metal parts. The purpose of bonding is to create a low impedance path for fault current to flow back to the source, which facilitates the operation of overcurrent protective devices like circuit breakers or fuses. Grounding, on the other hand, is the connection of the electrical system to the earth. This is typically done through a grounding electrode, such as a ground rod or metal water pipe. The purpose of grounding is to provide a reference point for the electrical system, which helps to stabilize the voltage and prevent electrical shock. The main bonding jumper is the critical link that ties the grounding and bonding systems together. It connects the neutral conductor of the electrical system to the grounding electrode conductor at the service entrance. This connection ensures that any fault current that flows through the bonding system will have a low impedance path back to the source, which will cause the overcurrent protective devices to trip and to energize the circuit. In the case of a mobile generator, the main bonding jumper is typically located in the generator's transfer switch. The transfer switch is a device that allows the generator to be connected to the electrical system of the building. When the generator is connected, the transfer switch will connect the generator's grounding electrode conductor to the neutral conductor of the building's electrical system. This will create a main bonding jumper that will ensure that the grounding and neutral systems are properly bonded. It is important to understand the function of the transfer switch in this process. A transfer switch is essentially an electrical switch that allows you to switch between two different power sources. In the case of a mobile generator, the transfer switch allows you to switch between the utility power and the generator power. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires you to manually switch between the two power sources. An automatic transfer switch will automatically switch to the generator power when it detects a power outage. Regardless of the type of transfer switch, it is important that it is properly installed and wired. This includes ensuring that the main bonding jumper is properly connected. The National Electrical Code, or NEC, provides detailed requirements for the installation of transfer switches and the connection of the main bonding jumper. These requirements are designed to ensure the safety of the electrical system and to prevent electrical shock. Article 250 of the NEC covers grounding and bonding requirements. Within Article 250, there are specific sections that address the grounding and bonding of generators. It is important to consult these sections of the NEC when installing a mobile generator to ensure that the installation is in compliance with the code. Some key considerations for grounding and bonding mobile generators are: firstly, the size of the grounding electrode conductor, which must be sized according to NEC Table 250.66 based on the size of the service entrance conductors. Secondly, the location of the grounding electrode, which should be as close as practical to the generator. Thirdly, the type of grounding electrode, which can be a ground rod, a metal water pipe, or another approved grounding electrode. Fourthly, the connection of the main bonding jumper, which must be made in accordance with NEC Section 250.28. Fifthly, the proper installation of the transfer switch, which must be done in accordance with the manufacturer's instructions and all applicable codes. Improper grounding and bonding can lead to a number of safety hazards. These hazards include electrical shock, fire, and damage to electrical equipment. It is therefore essential to ensure that all electrical work is performed by a qualified electrician and that all installations are in compliance with the NEC. When connecting a mobile generator to a building's electrical system, it is also important to consider the voltage and amperage of the generator. The generator must be properly sized to handle the electrical load of the building. If the generator is too small, it could be overloaded, which could damage the generator and the building's electrical system. The voltage of the generator must also match the voltage of the building's electrical system. In the United States, most homes and small businesses have a 120 volts or 240 volts electrical system. Larger buildings may have a 208 volts or 480 volts electrical system. It is important to ensure that the generator is compatible with the building's electrical system. The amperage of the generator must also be sufficient to handle the electrical load of the building. The amperage is a measure of the amount of electrical current that the generator can supply. If the amperage of the generator is not sufficient, the generator could be overloaded, which could damage the generator and the building's electrical system. In addition to the voltage and amperage, it is also important to consider the type of fuel that the generator uses. Generators can be powered by gasoline, diesel, propane, or natural gas. Each type of fuel has its own advantages and disadvantages. Gasoline generators are typically less expensive than diesel generators, but they are also less fuel efficient and require more maintenance. Diesel generators are more fuel efficient and require less maintenance, but they are also more expensive. Propane generators are a good option for people who have access to propane tanks. Natural gas generators are a good option for people who have access to a natural gas line. When selecting a generator, it is important to consider the cost of fuel, the maintenance requirements, and the availability of fuel. It is also important to consider the noise level of the generator. Generators can be quite noisy, so it is important to choose a generator that is quiet enough for your needs. Many generators have noise ratings that indicate how loud they are. These ratings are typically expressed in decibels. A lower decibel rating indicates a quieter generator. Another important consideration is the size and weight of the generator. Mobile generators are designed to be portable, but they can still be quite heavy. It is important to choose a generator that is easy to move and transport. You should also consider the storage requirements for the generator. Generators should be stored in a dry, well-ventilated area. They should also be protected from the elements. When storing a generator, it is important to follow the manufacturer's instructions. Proper maintenance is essential for ensuring the long life and reliable operation of a generator. Generators should be serviced regularly by a qualified technician. The maintenance schedule will vary depending on the type of generator and the amount of use it receives. However, some common maintenance tasks include changing the oil, cleaning the air filter, and inspecting the spark plugs. It is also important to keep the generator clean and free of debris. This will help to prevent overheating and other problems. In addition to regular maintenance, it is also important to take precautions when operating a generator. Generators produce carbon monoxide, which is a deadly gas. It is therefore essential to operate a generator in a well-ventilated area. Never operate a generator indoors or in an enclosed space. You should also install carbon monoxide detectors in your home or business to alert you to the presence of carbon monoxide. Generators also produce electricity, so it is important to take precautions to avoid electrical shock. Never operate a generator in wet conditions. You should also wear rubber gloves and shoes when operating a generator. In addition, it is important to keep children and pets away from the generator. When connecting a generator to a building's electrical system, it is important to use a transfer switch. A transfer switch is a device that allows you to safely switch between the utility power and the generator power. Without a transfer switch, it is possible to backfeed electricity into the utility grid, which can be dangerous for utility workers. A transfer switch also prevents the generator from being overloaded. Overloading a generator can damage the generator and the building's electrical system. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires you to manually switch between the two power sources. An automatic transfer switch will automatically switch to the generator power when it detects a power outage. Regardless of the type of transfer switch, it is important that it is properly installed and wired. This includes ensuring that the main bonding jumper is properly connected. The National Electrical Code provides detailed requirements for the installation of transfer switches and the connection of the main bonding jumper. These requirements are designed to ensure the safety of the electrical system and to prevent electrical shock. In summary, the main bonding jumper is a critical component of a mobile generator connection. It ensures that the grounding and neutral systems are properly bonded, which is essential for electrical safety. The main bonding jumper is typically located in the generator's transfer switch. It is important to consult the National Electrical Code and to follow all applicable codes and regulations when installing a mobile generator to ensure that the installation is safe and compliant. Remember to always prioritize safety when working with electricity and to consult with a qualified electrician if you have any questions or concerns. Ignoring proper grounding and bonding procedures can have serious consequences, so it's important to take the necessary steps to ensure a safe and reliable electrical system. Furthermore, understanding the specific requirements outlined in the NEC, particularly Article 250, is crucial for ensuring code compliance. This includes proper sizing of conductors, appropriate grounding electrode selection, and correct installation techniques. Always refer to the latest edition of the NEC for the most up-to-date information and guidance. By adhering to these guidelines and prioritizing safety, you can ensure that your mobile generator connection is both safe and compliant with all applicable regulations. The consequences of neglecting these safety measures can be severe, potentially leading to electrical shock, fire hazards, or equipment damage. Therefore, it is imperative to take the necessary precautions and seek professional assistance when needed to guarantee a secure and reliable electrical system. Understanding the nuances of grounding and bonding, especially in the context of mobile generators, is paramount for anyone working with or relying on these systems. From selecting the right components to following proper installation procedures, every step plays a vital role in ensuring the safety and functionality of the electrical setup.